So we have two problems left in this final practice for projectile motion. Number 3 says a diver jumps off of a pier at an angle of 25 degrees with an initial velocity of 3.2 meters per second. How far from the pier will the diver hit the water? Assume the level of the water is the same as the pier. So in my drawing, I have the pier and then the water is at the same level and the diver will take that path. The distance that the diver will land from the pier is the final x location times 2, because x sub f really only brings you halfway, and we want to know the entire distance. So first I'm going to just draw my triangle and set this up. So we have that the initial velocity was 3.2 meters per second and the angle was 25 degrees. Some things that we have for our table, we have the initial location is 0 and 0. The final location for the y direction is also going to be 0. We don't have the initial or final velocities. Acceleration in the x direction is 0 and acceleration in the y direction is negative 9.81. So from this point we can start to set up some equations. I'm going to find the initial velocity in the y direction and the initial velocity in the x direction just in case I need them. To find the initial velocity in the y direction, I use the sine function. And for the initial velocity in the x direction, I use cosine. And then I'll just solve these. From there I can find time. If I was just starting to look for the final x location, I would eventually run into the problem of not having time, so we might as well solve for that first. So even though I found t sub f, this is not total time. Total time would be 0.28. That really doesn't matter. But just to reiterate the concept of final time is not necessarily total time. That's just the halfway point. So now I have everything that I need to plug in to this equation. So I need the final location of x. The initial location was 0, so that just cancels out, and I'm left with the initial velocity in the x direction multiplied by the total time. So this gives me, oh, I should mention, we're going to have to multiply this entire thing by 2. So like I said at the beginning, x sub f is the halfway point, so we have to multiply it by 2. We can combine that here so that we don't have to do another step later on. So when you find out x sub f times 2, That will give you the final location or total distance. That's also total distance. And this comes out to be 0.8 meters. So quite a few steps just to find that one thing. Problem 4, we're finding two different things, but it's split into two separate equations or two separate parts. So we have a kicked soccer ball has an initial velocity of 25 meters per second at an angle of 40 degrees above the horizontal. Calculate the magnitude of the vertical component of the soccer ball's initial velocity and calculate the maximum height of the soccer ball. So initial locations are 0. We don't have final locations or initial or final velocities. Acceleration in the x direction is 0, and acceleration in the y direction is negative 9.81. I've already set up the triangle. For part A, we're just looking for the magnitude of the vertical component, so that's the y component. To find that, we use the sine function. So I have sine 40 degrees equals the initial y velocity divided by 25, and we rearrange this and find that it equals 16.1 meters per second. Then in part B, we're asked to calculate the maximum height. For this one, I have to find time. So I would originally have just gone with this equation to figure out the maximum height. But it ends up, I need time. So I'm just going to solve for time first. I actually didn't put it in the table, but the final velocity in the y direction would be 0, since it is no longer moving. So this would be 0. We calculated for v sub I, which was 16.1 meters per second, and then we have the acceleration in the y direction times time. And then this comes out to be 1.64 seconds for time. And now I can plug that back into the original equation up at the top. I'm going to leave units off because I don't want to run out of room. And at this point, it's really just a math problem. So the change in y, or maximum height, we've also referred to this as y sub f because the top portion of that trajectory. When you do the math out, you get that it's 13.2 meters. So that's all of the practice for this assignment. You can always look for additional projectile motion practice problems online, but at this point I would just recommend going back through and practicing any other problems from previous assignments.